Hello and welcome to the Mystery Polygon, my friends. Hey, this is an on-your-own problem, so you should solve the entire problem on your own, and now you're watching this video just to make sure you did everything correctly. Without further ado, let us move on to our scenario. Malevolent Myrdal is plain old evil. She traps animals just for the fun of it. Myrdal trapped Albert Baboon Einstein right here, and sure enough, look at, he looks just like Albert Einstein, doesn't he? Anyway, she trapped him just as he was about to solve the problem of global warming, my friends. We sure could have used that help, right? Anyway, will you please help Albert Baboon Einstein escape this coordinate grid that she has trapped him in, that Myrdal has trapped Albert Baboon Einstein right in there, right? So, solve the following questions, and Malevolent Myrdal will have to return Albert to his contemplation on global warming so he can solve the problem. Alrighty, the first thing you must do is graph the following points. You needed to graph A, B, C, and D. Let's go ahead and look at how those would look once they were graphed, all right? So the first thing we're going to do is graph A, and that is -7, -7. So if we start on the x-axis here, we're going to come all the way over here into the negative, down over 7, right? And then down another -7 right here. It only goes to -6, but you can see that this line here would be indeed -7. So our point's going to go right there. Let's go ahead and just enlarge this. And I want to make my point right there. So as you see, I went into the -7 and then down into the negative again, 7. And I'm going to plot this point as A. Let me enlarge this a little bit. And we'll plot it as A. And the coordinates are -7, -7. And that all goes in parentheses. So that's what your graph should look like to start with, right? And let's move on to point B. So for point B, you've got -5 and then a -2. So we can come right on up here and go first on the x-axis, -5, and then down to -2 here. And that's where our point's going to be. Let's go ahead and enlarge that and make that point. So once again, -5, -2 will be right there. So I'm going to make my point right there. And that is going to be B. So I'm going to enlarge this and write B. And in parentheses, I'm going to write -5, -2. And that all goes in parentheses. So that's what that should look like right there, my friends. And now let's move on to plot point C. So if we come over here, we can see that point C is going to be +7, -2. So let's come back over here again. This time, we're going into the positive on our x, +7, and then down -2. So we'll be right there. So let's go ahead and plot that point. And once again, we've got +7, -2. So we'll be right there. And I'll plot that point right there. And that, my friends, is going to be point C, right? So I'm going to write C, and that is at +7, -2. And bam, there you have it. So that's what that point should look like. And so far, your paper should look just like this, right? Let's go ahead and see what we're going to have here for D, all right? So for D, we're going to go into the +5 places and then down -7. So we're going to come on the x-axis over 5 and then all the way down here. Once again, -6 is here, so -7 is right there. And we're at +5 and then -7. Let's go ahead and plot that point. And here we go. So I'm going to just do this once again. Over 5 into the positive and then down 7. So our plot's going to go right there. And I'm going to make that right, bam, right there. And that is D. Let's enlarge this so I have a little more room. And it is D. And the coordinates are +5, -7. And that all goes in parentheses. And bam, that is what your graphing should look like. A, B, C, and D right there. And let's move over here and look at what our problem is for number 2, my friends. And for number 2, we need to connect all the points going from alphabetical order, or how about going in alphabetical order? Alrighty, super. So we're going to go from A to B to C to D and right on back to A. Let's go ahead and do that. I'm going to enlarge this a little bit and we'll do this in green. So from A to B, I'm going to just draw my line like that. From B to C, I'm going to draw a line straight over there. From C to D, I'm going to draw it straight down there. And from D to A, actually I'm going A to D, but same thing. And right on over there. And bam, there you have it. You've got these lines all connected, and it should go in alphabetical order and should look like that. Alrighty, let's move on to question number 3. What is the distance from point A to point D? So we're going to go right here from point A straight across to point D. So now there's a couple of different ways I can do this. First of all, as we talked in prior videos, each one of these squares represents 1 unit if you go from here to here. So I can count these units all the way from A to D, and let's do that right now. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 units from here to here. So let's just go ahead and write our answer in right here. And bam, there you have it. This is what you should have on your paper, 12 units. But I'd like to go ahead and look at this a slightly different way. So now I can also think of this as in terms of absolute value. So even though this is in the negative, as you see, I am -7, right? So that -7 there represents these units here, 1, 2, 3, 4, 5, 6, 7, -7. And I can think of that in terms of absolute value of -7, right? And put that there. And now over here, this is +5, which is represented right there. 1, 2, 3, 4, and 5 places. So I can think of this as adding the absolute value of +5, right? And when I take the right here, the absolute value of -7 plus the absolute value of +5, I am going to get exactly 12 units. But wait 1 second, because I want you to see what's happening with the coordinates here, okay? So here I have A, which is -7, -7, which is represented right here with this point. And then I have B, which is 5 and -7, or 5, -7, which is represented right here with this point and these coordinates. Now, as you see, this column here is my X column, okay? And that's how far both these points are from 0 on the X column, either in the negative or in the positive, okay? And this Y column is just how far we are down in the negative. And they're both on -7. So there's absolutely no difference between -7 and -7. That's why that's a 0. Now there is a difference between -7 and 5 and +5. So what I've done here is I've taken the absolute value of -7 plus the absolute value of 5, and that gives me 12. So you get 12 units, which once again agrees with our original answer right here of 12 units. So you could either count the linear squares, right, from A to D, or you could use your absolute values like this, or you could also use the coordinates and solve for it that way. Either way, you're going to end up with 12 units, and that, my friends, is how you solve that part of this problem. Let's move on to what kind of polygon is Albert Baboon Einstein trapped within? And clearly, this has 1, 2, 3, and 4 sides, so it is a quadrilateral, but exactly what kind of quadrilateral is it? Well, this line is parallel with this line, right? And this line is parallel with this line. And this line is the exact same size as this line, otherwise known as congruent. So this is congruent to this. And this line is congruent, or the same size as this line. And that makes this quadrilateral a parallelogram, my friends. And hey, that is all you needed to do to solve this entire problem. And if you got everything correct, well, good for Albert Baboon Einstein, because he gets to go back and contemplate and solve the problem of global warming. That is very nice. It frees him from the coordinate grid. Bam, perfect. However, if you made a mistake anywhere along the way, you know by now, no worries at all, my friend. Pause that video, fix that mistake. That is your fastest way to learn. Until next time, I hope you have a fantastic day. Well, see you soon.